yesterday and just now going over the homework quiz. So for independence, essentially the conditional probability test, and I'll categorize this, the conditional probability test, which is what I usually do, is when you compare the probability of A versus the probability of A given B. That's the conditional probability test. The multiplication or the multiplying probability test, which just from the way I've seen them phrase questions, they usually don't go this route, although they have. You would check and you would compare the probability of A times the probability of B, and you would check whether or not that equals the probability of A and B. And they really have to write it just so for that to be possible. There was one on your homework last night where they had you do that. So this is where I'm saying I've kind of already taught this, obviously. The product test for, what is this, smoker and emphysema, you would do the probability of being a smoker times the probability of having emphysema, and you would compare it and see whether or not it equals the probability of being a smoker and having emphysema. So based on this Venn diagram, the probability of being a smoker and these are percentages, and having emphysema is 14%, 0.14. The probability of being a smoker alone is 0.34 times the probability of having emphysema alone, the emphysema circle, is 0.18. And you would check that. If that multiplication equals 0.14, then they are independent events. I think just by the nature of what you know health-wise about smoking and emphysema, I think it's pretty obvious that they're not going to be independent events, right? There is something about smoking that correlates with emphysema. We all get that. So they won't be equal, and if they're not equal, they're not independent, which sort of implies that there's a correlation causation thing going on. Okay? Let's flip to the back. Cross out that first one. I've always hated that problem. I don't want to discourage you. Get rid of that. But just in this last one here, or second to last one, with males and females from a chart, it wants us to do the two different methods of determining independence. Whether the events of being a male and passing are independent or not. So, tell me, Vince, what calculations I can do and compare that would be the conditional probability test. Well, no, tell me, don't give me numbers. Tell me what I'm calculating first. Well, I got to calculate probabilities, my friend. Look at this. Probability of A versus probability of A given B. What probabilities? Tell me what A is and tell me what A given B is. Probability of male, and I'm going to compare that to the probability of what? Male, not male and passing. Probability of being a male given passing. Now hit me with the numbers, Vince. What's the probability of being a male? Very good. And what's my probability of being a male given that I'm passing? 66 out of 120. Very good. So you look at your passing category, and we're just going to compare those. So 110 out of 200, 0.55, versus 66 out of 120, 0.55. So they are equal. So did my probability of being a male change? No. So whether or not I pass is independent. Okay, that's the given test. By the way, Vince could have done probability of passing and compared it with passing given male. He would have gotten a different number, but they still would have matched, is the important part. Capiche? And the multiplication one, tell me the probabilities that I have to calculate and compute with there, Owen. Very good. Male and passing. Okay? So my probability of being male, Tess, is what? (110 out of 200). There are 110 males out of 200 people total. What's my probability of passing, Eric? There's only 66 people that passed? How many people passed? 120 out of 200. Unless it's a given probability, it's going to be out of the total. Yes? The 200. And then we're going to compare that to what are the chances that someone was a male and passed? Haley? Out of what? No. No. This is not given probability. This is just of all the people surveyed, how many of them were male and passed? 66 out of 200. The only time your denominator gets adjusted is if it's given probability. Process that sentence that I just told you. The only time your denominator changes is if it's given probability. Meaning you're limiting the population that you're looking at, like up here. I was only looking at the passing people. There were 120 of those. Of those 120, how many were male? You see the difference? So when I multiply those, 110 out of 200 times 120 out of 200, I get, don't move an inch, 0.33. And 66 out of 200, also 0.33. They equal, so they're independent. Capiche? And of course, if one test worked out to tell you that they were independent, then the second test did as well. So, you pass those out. And rather than a spiral, because you have a test coming up on Tuesday, I'm going to give you a review sheet as your spiral. Okay, because this is that was the last thing of the probability chapter. Take one, pass it around. Let it snake through. And so, what's that? Tuesday. We're going to review the review sheet on Monday and the homework, and then talk about whatever, and then test Tuesday. So rather than a spiral, I'm giving you a review sheet. Okay, so you want to take it Monday.